Okay, so absolute value equations is where we're at. Okay, this is section 9.2 in unit 4. So what we're looking at here is we've talked about absolute value expressions before, right? So we've already kind of looked at stuff that said like the absolute value of 3 is positive 3, and the absolute value of negative 3 is also positive 3, because you're talking about a distance away from 0. So from 0, right, to the left would be 3 units, okay, and to the right would also be 3 units. So if you're talking about a distance and we don't care what direction, I could go either way and get 3 units. So negative 3 and positive 3 would both be the same distance from 0. So that's why the absolute value of 3 is 3 and the absolute value of negative 3 is 3. Okay, so before we kind of gave you the absolute value part and we had to find what it was equal to. Well, now we're going to kind of work the other direction. So now they're going to tell us what it's equal to, and we need to figure out what could possibly be in here. Okay, so if my distance is 3, that means I could have been at negative 3 or positive 3. Sorry, negative 3 or positive 3. Okay, because both of those would be a distance of 3 away. The absolute value of 3 would be 3. The absolute value of negative 3 would also be negative 3. Okay, so that's kind of what we're looking at. So when I'm solving equations with the form absolute value of x is equal to a, okay, if a is a positive number, and this is important, it has to be a positive number, because once I take the absolute value, okay, it's going to become a positive number. So the absolute value can't be negative. Okay, so if a is a positive number, okay, then the absolute value of x is equal to a is equivalent to x is equal to a or x is equal to negative a. Okay, same reason. This part in here, okay, if it's positive a, the absolute value of positive a is a, so x could be a. And then the absolute value of negative a is also positive a, so x could be negative a as well. Okay, so that's basically what we're looking at when you're looking at absolute value equations. You're going to end up with these two different solutions because the inside here could be positive or negative. So for instance, on example 1, okay, the absolute value of 5w plus 3 is equal to 7. Well, that means this piece right here, okay, could be positive 7, right? Because if this part right here is positive 7, I'd have the absolute value of 7, which is 7. Okay, so that would work. But this part could also be negative 7. So 5w plus 3 could equal a negative 7. Okay, because if this is negative 7 inside, okay, so if 5w plus 3 becomes a negative 7, well, the absolute value of negative 7, again, is also 7. Okay, so that's why we have these two separate answers. This inside could have been positive 7 or negative 7. So now from there, okay, you just solve each of those equations to figure out what w could be to give me positive 7 or negative 7. Okay, so we'll subtract the 3. Okay, this is basic solving. This is back from Unit 2, so if you're having problems solving, you can always go back and check there, right? But we want to isolate our variable, okay, and then we get the variable by itself by dividing or multiplying. Here we divided, so we get w is equal to 4/5. Okay, do the same thing over here. I'll subtract the 3. 5w is equal to negative 10. Divide by 5. And w is equal to negative 2. Okay, so there's my two answers. And if I were to plug those in, okay, and if you can kind of sort of check that real quick, if I plug this in, 5 times 4/5 is 4, plus 3 makes 7. The absolute value of 7 is 7, so that checks. Okay, same thing here. 5 times negative 2 is negative 10, plus 3 is negative 7. Absolute value of negative 7 is positive 7. Okay, so you get those two answers. Sorry, I got the hiccups. And I apologize for the sniffles. I'm kind of sick a little bit too, so if I sound funny or you keep hearing me sniffle, I'm trying not to, but I am a little sick, so apologize for that. So, okay, so same thing for the second one, right? Okay, one of the most important things to remember is that you are never going to take something out of that absolute value until you set these two different equations up. Okay, you'll never like minus a 3 out of an absolute value. You'll never multiply stuff into an absolute value. You're not allowed to do that because this absolute value has special properties. Okay, so the stuff that's inside of that absolute value is also special, so you can't just plus 1 to the other side. That doesn't work. Okay, this right here is part of this absolute value. So the only way to get rid of those absolute value bars, okay, is to give us the two separate equations. So now we're working with what's in the absolute value. So this right here could be positive 11, or it could be negative 11. Okay, so notice when I rewrite them, I don't write absolute value because I'm really just talking about the inside part, right? This could be positive 11. This could be negative 11, right? The absolute value itself is still going to be a positive 11. That's not changing. That's not what we're doing. Okay, we're saying that this inside could be positive or it could be negative. Okay, so then again from there you just solve. So plus 1. Okay, so x over 2 is equal to 12. Okay, to get rid of that divide by 2, you multiply by 2, right? So that 2 and 2 cancel on the left-hand side, and I get x is equal to positive 24. There's the first answer. Do the same thing on the right-hand side, plus 1 to both of them, so we get x over 2 is equal to negative 10. Multiply by 2, and we get x is equal to negative 20. Notice it did not just come out positive negative 24 or 20, right? Okay, so you actually do have to do the split and do two separate problems because the answers are usually going to be different. They can be the same where one is just positive and negative, okay, and I think we see one of those in a second, but they're not usually. So make sure that you actually take the time to split them here and then solve both problems because they're going to be different answers. Okay, so example 3, same sort of thing, problem being that you have to isolate your absolute value first. Okay, so isolate your absolute value first. Isolate absolute value first, right? Because this right here is the only thing that has the potential to be plus or minus. Okay, this right here is not going to change. This plus 5 is just a plus 5. Okay, so before we can start doing our split, we really want to get this absolute value all by itself so that it's in this format, right? Absolute value of some x is equal to some number. Okay, so that's what we're trying to do first. So we want to isolate this term first. Okay, so I'm going to minus the 5 to the other side. Now I've got the absolute value of 2x is equal to positive 2. And then once I'm here, now this is allowed to be positive 2 or negative 2. So let's go ahead and set that up. So 2x is positive 2 and 2x is negative 2. Okay, and let me kind of say that again. So from here, I can't just say plus and minus 7. Right, because plus and minus 7, that plus 5 is still in there. So if I were to minus a 5 to a negative 7, that gives me negative 12. That's something totally different, right? Because then you're kind of saying that this plus 5 could also be plus or minus, and it's not, right? This plus 5 is not in absolute value, so it's always just a plus 5. And when I minus it over, it's just a minus 5. It can't just switch like that. Okay, so make sure you isolate and then do your 2 and then do your solving. Here we go. Divide by 2, we get x is equal to 1, or divide by 2, x is equal to negative 1. So there would be my two answers, okay? Doesn't really matter if you write or in between, you just need to have both answers. Okay, so same thing for example 4, oops, too far, there we go. So same thing for example 4, we're going to isolate first. So minus the 25 over, minus the 25, I get 2, absolute value of x is equal to negative 2. Okay, the 2 out front is not inside of that absolute value, so it does have to go. Okay, different from here, this 2 was inside the absolute value, so it stayed until we did the split. This is outside of the absolute value, so before I can split, that needs to go. Okay, so we get absolute value of x is equal to a negative 1. Now, typically we would split this and do x is equal to negative 1, x is equal to positive 1. Okay, don't write this down. X is equal to 1, x is equal to negative 1. That would typically be what we would do. Okay, but the problem is the absolute value of 1 is 1, not negative 1. The absolute value of negative 1 is 1, not negative 1. Okay, so these don't work at all. And if you go back to what our definition was, the absolute value of x is equal to a if a is a positive number. Okay, because the absolute value is always going to be positive. The absolute value of x or of any number is going to be a positive answer, right? Because we're talking about the distance. So the negative goes away. So what that means is the absolute value can never equal negative 1. Okay? If it can't equal negative 1, then there is no solution to this. There's no number I can pick to plug in here that's going to give me a negative after I take that absolute value. Okay? So make yourself a little note here. Okay, absolute value cannot equal a negative. Ever, right? Cannot equal a negative because it doesn't make any sense because the absolute value of negative 1 is positive 1, not a negative. So, when you get to example 5, right, you're done. There's nothing to do. The absolute value of this equals negative. It's already isolated. okay, which we do need to make sure it's isolated first, but absolute value is by itself on the left-hand side, okay, and it's equal to a negative number, automatically no solution. Okay, do make sure you isolate though first, because you will have some cases where you'll end up with something like this, minus 5 equals negative 3. Okay, so here you got to be careful, because some people will just jump straight through and say it's equal to a negative, it's no solution. But that doesn't work here, because once I isolate my absolute value and I add the 5 over, absolute value of x plus 2 equals positive 2. Well, now it's equal to a positive, and I can answer that. So I would keep going from there, set up my plus and minus 2, and keep going. So make sure you isolate before deciding that it's going to be a no solution, okay? Because you want the absolute value to equal a negative, not the absolute value plus or minus a bunch of stuff, okay? So make sure you do that first, okay? So now, example 6. This was just like a made-up example, by the way, so I just kind of added that along. All right, so example 6. Now, people like to skip this one because it looks really hard, but it's not actually bad. It's the same thing, okay? We're going to do a positive and a negative. So the positive one really just looks exactly like this, okay? 3x plus 2 is 5x minus 8. Okay, it looks exactly like that because these things are going to be equal, because you got to imagine that this could be positive equals positive, whatever the number is. This could be negative equals negative, whatever the number is. It could be negative is positive and positive is negative. So there's all kinds of things going on here, okay? But to create those possible answers, we make a positive and a positive, so just leave it the same. It has a minus sign, that's fine. I leave it exactly the same. That's what we call our positive form, okay? And then solve that, okay? Or we have our negative form. Okay, so just like we did on all of these where we did positive and negative, okay, we have our positive and then negative. You're going to leave the left-hand side the same and make a negative out of the entire right-hand side. Now, technically, you could do a negative of the first side and leave the right-hand side the same. That's fine. So I could do negative 3x plus 2 equals positive 5x minus 8. That would be perfectly acceptable. Okay, what you can't do is change them both to negatives, because changing them both to negatives really just makes it back like this again. Okay, so don't change both sides, only change one. So I leave my first the same, I make my right-hand side negative. Okay, so now after that, there's my two answers. So we're going to go ahead and solve those. Okay, so we're going to move our 3x to one side, done. We're going to move our 8 to the other side, done. 2 plus 8 makes 10. 5x minus 3x makes 2x. Divide the 2 away. X is 5, there's 1. Okay, and then this one right here, we're going to distribute that negative. Make sure you distribute the negative. Everything on the right-hand side should change signs. Everything should change signs. Say that one more time. Everything on that right-hand side should change signs. Everything on the left-hand side should remain the same, or those things can be switched and go vice versa. Okay, so 3x plus 2 is negative 5x and positive 8. Positive 5 to negative 8 became negative 5 to positive 8, right? Because I distributed that negative. So now, this is like my negative form. So now I solve that. So plus 5x. Boom, gone. Minus 2. Boom, gone. So I get 8x is equal to 6. Divide by 8. X is equal to 6/8. Do not leave it like that. That's just bad math. Okay, reduce those, right? So you can divide a 2 out of each one of those if you want to, and you get x is equal to 3/4. Okay, x is equal to 3/4. Okay, so now the last one that's on there, which I suggest that you turn this off and give it a shot on your own, see if you can figure it out. Okay, and I'm going to go ahead and keep doing this because you can always hit the pause button since you're watching a video. So here we go. So absolute value of x minus 3 is equal to the absolute value of 5 minus x. Same thing. I've got an absolute value on both sides. They're both isolated. Okay, so here we go. Absolute value is isolated, so we go x minus 3 is 5 minus x. The first one is exactly the same. I don't change anything. Okay, only thing I do is get rid of the absolute value signs. Okay, then the second one, x minus 3 is equal to a negative of that right-hand side. Okay, a negative of that right-hand side. Alright, so now solve. Plus x plus 3 plus 3. Okay, 2x equals 8. Divide by 2, x is equal to 4. There's 1. Okay, do the same thing for the second one. Here we go. X minus 3, negative 5, positive x. Okay, so here, when I go to subtract, boom, minus x plus 3, just like we normally would, right? Okay, but when I do that, x minus x is 0. X minus x is 0. Don't try to keep an x there, okay? It's just like over here. X minus x was 0 on this side. X minus x is 0 on this side. So it cancels. I end up with 0 equal to negative 2. Okay? That is not a true statement, which means this thing right here is a little no solution. But that's only for this part, right? This was an entire equation, and we already found one answer. Okay? This does not yield a solution, but this did. So there's only one answer this time. And that answer was 4. So that's what I have boxed in, x equals 4. I did not box no solution. Don't box no solution. Just box the x equals 4. We only have one answer this time. This itself just yielded no solution. Okay? Alright, so that's really it for absolute value equations. Not a whole lot more to that. You get to see a lot more of them when we do absolute value inequalities, which is the next section, 9.3. Okay, good luck with that.